Now in this video we're going to talk about molar and mass solubilities. Now the thing about molar mass solubilities is it basically says we take a solid and we put it in water. And let's say we have an excess amount of the solid, so we end up with a saturated solution, meaning that the solid's there, but it's definitely dissolving and reprecipitating out. And we're at equilibrium concentrations of the ions in solution. The molar solubility says how many grams or how many moles of this material will dissolve in a given liter of solution. Now, this sounds like a complicated problem, but actually you've got most of the components done if you've gotten to the point of a molar solubility question. So in the back I've got a KSP problem here. Now KSP problems, you go to previous videos, you'll see ones about how to find KSP from concentrations and how to find concentrations from KSP. Regardless, when you solve those types of problems, you end up with an IC table that's completely populated. So you've got the equilibrium concentrations, you've got your KSP, and you've got your extensive reaction. In this table, you actually have the molar solubility, but it's cleverly hidden in one of the rows we got rid of. So when we solve KSP problems, we typically eliminate the PBr2 or the solid phase. So in this case, we have PBr2 dissolving the lead and bromide ions, but we get rid of the solid because its concentration is not changing, it's a solid. So within its own phase, concentration doesn't change, so we just ignore it. It doesn't show up in our expression for Q. But if we were to continue to have this column, we would have a negative X in its row. This negative X is actually where we're going to backtrack out the molar and mass solubilities. So if you've gone through this whole table and solved it, odds are you're going to have to do anyway, your molar solubility then is just the X, the extent of reaction. So for any IC table, because it's typically 1 with regards to the whatever solid's being dissolved, we can equate the molar solubility to the extent of reaction because it basically says how many moles of the PBr2 dissolved in the given liters of solution. And those are the units of molar solubility, moles of solid per liter of solution. Now let's say we want to go to the mass solubility. This is actually just as equally easy. We've got our molar solubility, which is defined as moles of solid per liter of solution. To get our molar solubility, all we have to do is take our mass solubility, our molar solubility, and multiply by the molecular weight of the solid. So if we take our extent of reaction and we multiply by the molecular weight of whatever the parent salt is, in this case PBr2, this will give us our mass solubility. Now sometimes this will be defined in grams per liter, sometimes it will be defined as milligrams per liter. I hope that at this point in chemistry you know how to convert between grams and milligrams. But basically, define the mass solubility, it's just the molar solubility, which is in moles per liter, converted to grams per liter. So that's it. It's actually very straightforward. Again, if you've already filled out this IC table to find your molar solubility, just your extent of reaction, because there's always one coefficient on the parent salt. To find the mass solubility, just take this extent of reaction, multiply by the molecular weight of the parent solid, and that'll give you the mass solubility.